Good morning, students. Today is July 5th, where this is Math 2008. We're going to work on a section that we didn't do earlier, 6.3. We're going to work on 6.3. It's not a very difficult section. By the end of our lecture today, you should be able to do the problems from 6.3. They are available. All right, guys, so let's start. This is about division and multiplication of fractions, okay? Now, we're going to do a lot of things visually. Okay. Now, when you have two fractions, how do you multiply them? I'm going to show you first. 2/3 times 3, let's say 3/5. How would you multiply these two fractions? And if you don't mind, I'm going to make it 4/5. Okay. You, you multiply the fractions by multiplying the numerators. In this case, it will be 4 times 2, 8. And then you multiply the denominators. In this case, it will be 3 times 5, 15. Now, many of the problems we will do, you won't have to use the multiplication rule. It's called an algorithm. You don't have to, but you can. If you can see that it's a multiplication problem, be my guest and use it. So this is called the multiplication algorithm, multiplication of fractions algorithm. What's an algorithm? And you're going to hear it a little bit from me. Algorithm is a step-by-step rule that allows you to get to the right answer if implemented correctly, of course, right? How do we divide a fraction by another fraction? Let's say I want to divide 2/3 by 4/5, the same two numbers. 2/3 by 4/5. Now, I can't really write the division sign properly here. So what I'm gonna do, give me 1 second, okay? I'm gonna bring it from someplace else and it'll look a little better. So here we have it. All right. So let me do it nicely. All right. So how do we divide a fraction by another fraction? Well, what we do is we take the first fraction and leave it alone. And then we find the reciprocal of the second fraction, which simply means you flip it. The denominator becomes the numerator, and the numerator, which is 4, becomes the denominator. Now, if you want to cancel 2 and 4, you can, but you will be really multiplying the numerators and the denominators just like you did before. But here they do cancel, so I can write a 2 here. And now your denominators are 3 and 2, which is 6. 3 and 2, which is 6. And on top, you just have 5. I'm going to write it nicely, okay? 5/6 is your correct answer. Once again, how do you divide a fraction by another fraction? You leave the first fraction alone, and you take the second fraction and you flip it. It's called flip and multiply algorithm. All right, it's a very basic concept, but we're going to do more than that. We're going to be showing you what it really means to multiply and divide two fractions. Okay, we're going to try to understand what it really means. All right, we're going to move on. So, all right, so here it's now I am getting this slide from your text, but it's a good slide. It's worth discussing. So they're showing us 3/4. Here, 3 times 3/4. That simply means 3 copies of 3/4. If this is 3/4 of a pi, this is 3/4 of a pi, this is 3/4 of a pi. 3 times 3/4, 3 times 3/4 is simply 3/4 plus 3/4 plus 3/4. And if we put all the things together, all the pieces we try to fill in the first pi, you will have, take a look. This is all here, and this is all here. And I'm going to take this guy, and this guy, and put them here, here, and here. So what you get is equivalent to 2 1/4. And of course, 2 1/4 can be written as 4 times 2 is 8, 8 plus 1, 9, 9/4. We kind of saw how to convert an improper fraction to mixed number. So they're kind of trying to show you how it works visually. Let's look at a few more examples of visual multiplication from your book. Okay, this is another good one. Now, take a look. They're saying, how would you do half times 1/8? Now, half times is half of 1/8. So I know you can see it, but let me give you a simpler example. It's going to be exactly the same. Let's say I want you to show me what's half times 1/3. Okay, that's really same as half of 1/3. Okay, half of 1/3. So I'm going to start with 1/3, and I'm going to take the two denominators, 2 and 3, and I'm going to make sure my whole has 6 units. It's called taking a 2 by 3 rectangle. Now, 2, I already have one. You don't have to know how I made it. So I have a 2 by 3 rectangle. It has 2 rows and 3 columns. Okay. Now I'm going to first shade 1/3. That's going to be 1/3, and I'm shading it pink. Okay. Now, I don't want 1/3. I want half of 1/3. So what do I do? Let me do this. Let me take a rectangle. I want half of this pink stuff, only half. I don't want the whole thing because the question says half of 1/3. Well, half of 1/3 is actually 1/6. Take a look. If this is your whole pizza, okay, and you ate 1/2 of a third of the pizza, what would that mean? What part of the whole pizza did you eat? You ate 1/6 of the whole pizza. Now, if you do multiply the top and the bottom, you're going to get the same answer. 1 times 1 is 1, 3 times 2 is 6, and that's what you're going to get. And that's exactly what you're getting visually when you see this as a multiplication problem done visually. We're going to do a lot of things in this section visually. There are a couple of problems that are kind of interesting. We'll do them visually. And here is one example from your book, half times 1/8. And I did another one, half times 1/3. Okay, guys? Let's see what else is coming up. Now they have a couple more. I'm going to do a couple more. Okay. Um, I'm going to do one more from your book. It's an example from your book. I know you can see the picture, but I'm going to do this one. 2/5 of 1/4. Well, I am first going to take, now I can do the rest too. It takes a while to draw those boxes, but it's not going to be too bad. I'm going to take 5/4. It doesn't matter how you draw the rectangle, okay? As long as it has 5 rows and 4 columns, or 4 rows and 5 columns, you will be fine. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now I do have, just to let you know, guys, we're doing this one, just so that you know. We can do any one of them, but this will take a little less of our time, but it's the same thing, and you do have the pictures there. So guys, I'm going to first shade 1/4. Clearly, it's 1 out of 4. This whole rectangle is a pizza or a bar of candy, right? 1/4 would be one of the columns. And I'm going to shade it pink. Now, I don't want 1/4. What do I want? I want 2/5 of that. Well, 2/5 of that would be this, what I shaded has 5 equal parts. I only want 2/5 of them. And I'll try to see how I adjust the size. Well, 2/5 has to be this much. 2 out of 5, right? That's all they're saying. Now, you could make this rectangle bigger. It's not going to make any difference. It will still be this much. Okay, you will be shading 2 parts out of the 5 of the pink rectangles you have. Now, the final answer is, what part of the candy bar did you eat? If you ate 2/5 of 1/4 of the candy bar, what part of the whole candy bar did you eat? Well, you ate 2 out of 20. You ate 2 out of 20. Now, 2 out of 20 is 1/10. 2 out of 20 is 1/10. Got it? All right. So again, we're going to do most of the things visually in this problem, in this section. There are a couple of problems. This is an example from your book. I will do it visually, and I'll do a couple more. The ones that I'm going to do from your book are also the ones that I have assigned uh, on your as your homework problems. Okay, so you want to make sure you understand those. All right, so let's see. The bicycle is on sale at 3/4 of its original price. Okay, 3/4. Well, so I'm gonna make sure the price of the bicycle has 4 parts, and they are charging you only 3/4 of the price. And what they're charging you, I'm gonna shade it, let's say yellow. So you're being charged only 3 out of 4 parts of the original cost. And the sale price is the price that you pay, is $330. What does that mean? Well, that means the yellow part is $330. Okay. This is $330. All right. Now, they want you to find the original price. The original price, well, if 3 of the yellow parts are going to be together 330, you're going to take 330, you're going to take 330 and divide it by 3, and you will get 110. Each box is worth $110. I'm just going to write 110. Well, I can write dollars. Each box is worth $110. Well, what do they want us to find? They want us to find the original price. So the original price was the whole rectangle with 4 parts. Each part was 110. You take 110 multiplied by 4. And that's your answer. Not that bad. Okay. Picture is worth 1,000 words, and it works for fractions. All right, guys. Let's try one more problem. I think you should be able to handle 14. I'm going to try 15 and 16. Okay. Now, let me see how I can grab it from here and be a little patient. Let's work on 15 first. John took all his money out of his savings account. He spent $50 on a radio, three-fifths of what remained on presents. Half of what was left he put in his checking account. So, guys, we have two fractions here. Of course, I can read the whole thing. Actually, I've read it earlier, so I kind of know what's going on, but let's see what's going on. I have a fraction that is clearly three-fifths. I can see that. And there's this half. Half is, of course, 1/2. Okay. So I'm going to take these two fractions, this one and this one, right? I have 5 and 2. So I'm going to make a rectangle that's 5 by 2. I'm going to make a rectangle that's 5 by 2. Now, don't forget the $50 he spent on radio. I'm going to write it on the side, okay? $50. I'm going to write it as follows. So they want us to know how much money he had. And what he had is given by two things. He spent $50 on a radio. Then he took three-fifths and bought some presents. Now, look at this rectangle. This has 5 equal parts, and he took three of them. Now I have to move the $50 here. He took three of them. I'm going to shade it yellow. And what did he do? Went to presents. He bought some presents. I'm just going to, if you don't mind, I'm going to write P. Okay. Now, half of what was left, this was left. Half of this was put in checking accounts. I'm going to shade half four. What's half of four? Two. Let's see how I can do it. Doesn't matter which two you shade. I'm going to shade these two green. Sorry. I have to be careful. I just have to shade two of them green. All right. So this went to the checking account. CA, CA. Now, the remaining $35 was donated to charity. This has to be the $35. This has to be the $35. Now, the question says, how much money did he have originally? Well, if two rectangles is $35, this 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 is $35. So the whole rectangle must be worth what, guys? The whole rectangle must be worth 5 times 35. Okay. Each pair is worth $35. And since they want you to find the total amount of money that so what's 5 times 35? Let me use my calculator if you would be okay with it. So 50 plus 5 times 35, 50 plus 5 times 35. I'm getting $225. Take a look. It's a very easy problem if you draw the right kind of picture. In summary, I'm going to go over it once again. The two fractions you have, 5, 3/5, and 1/2. Look at the two denominators. Denominators are 2 and 5. Half is 1/2. So the denominator is 2 and 5. You take a 2 by 5 rectangle and everything falls into place. All right, guys? Okay. One more problem. All right. Now, this problem is also very interesting. We're going to do work backwards. Okay. We're going to work backwards. It's a very common strategy, and we're going to try to do it visually as well. All right. Al gives half of his marbles to Bev. Bev gives half of these to Katrina. Katrina gives half to Danny. If Danny got 4 marbles, so I'm going to make a table. I'm going to walk you through. Okay. I'm going to write Al. Give me 1 second. Okay. Bev, Katrina, and Danny. Now I'm going to start with Danny because Danny received 4 marbles. All right. I have to find out how many Al had. Now, remember, Trina gave Danny half. So Katrina had the other half. So Katrina must have had 8 marbles because half of 8 is 4. Now, Bev gave half of her marbles to Katrina. If Katrina had 8, Bev must have had 16. Well, if Bev had 16 marbles or received 16 marbles from Al, how many marbles did Al have to begin with? Al must have had 32 marbles. That's your answer. See how easy it is if you understand what fractions mean? You don't have to write an equation. You can conceptually solve the problem. Okay, I hope that helps, guys. That's all I have for today. If you need homework problems, exam problems that you couldn't do, please email me, mention the name of your class, mention the problem number. If it's an exam, give me a screenshot, whatever, wherever the problem is coming from, give me a screenshot. I'm teaching a bunch of courses. So it's a little hard for me to kind of figure out which section things are from. So some of the sections do overlap a little bit, including this one. This one kind of resembles a little bit 6.2. This is 6.3. So give me a good screenshot for your, if you want me to do something. By the way, the answer to this problem is, let me write it down. The answer is 32. Okay. All right. See you next class.